So today I will discuss the division algorithm for how you can implement the division in the VHDL. Okay, division. In the Xilinx the division is not working. May I want to say that the normal division the slash is not work. So we have to do something to implement this. You can use the restoring division algorithm to implement this. You can use the non-restoring division to implement this. In this video I will show you the restoring method. If you do not know the restoring division algorithm in pen or paper, you can watch a video, but I will go through my algorithm, my code, and you can bit understand how it works or something. So you can see today I not first of all I not open the Xilinx app. I'll show you in my website. You can if I will show you the code, go through it, and then you will and go to the code and you will see. Okay, so start. See what will happening here. So these things you can see that the A B and Q are the four the port or pin numbers, where the pin numbers, and both all are vector type, means array type, and having 7 to 0 bit. 7 to 0 means total 8 bit. Means I will design a 8 bit divider. Okay, so 8 bit divider, and in the multiplication you see that if you multiply to 4 bit, then its output will be 8 bit. But in the division there is no way, there is no such things that if you divide something it will reduce or increase. If you divide to 7 bits, then remains in also in 8 bit. Okay, if I just 8 bit divide, and so the you can understand these things. Now see, in here you use the for loop. Okay, if you for loop and if else. Okay, if you use the for loop, you have to begin a process. What is process? You can understand is like a callback function in JavaScript. Like, okay, it have two parameters. You see the two parameters are the input of your input, basically their input, the input pins, only the input pins. No, there is no need to give the output pins. Okay, so just give your in the process the two parameters are two input pins. Now here you have to just take some variables which are something division, dividend, which are 7 bits, and the quotient and remainder are the variables where also the 7 bits. But here is a catch. You see, unsigned of 7 down to 0. What this means? What it means? It means the unsigned, it will take, it is not a vector, it is not a vector, it is a regular number, regular integer number. It is a regular integer number. Okay, so you can regular integer number which is having the 8 bits, which are having 8 bits total. How many bits? There are 8 bits. Okay, just like, okay, and if you use the unsigned function, you have to import a library called the numeric underscore std.all. What means all? Means all the library having all the modules you are importing from the GCC compiler from the library. Okay, no, now the you can understand the variable part. Okay, now I will go and start here. Suppose here you can see that I assigning the divide dividend variable to my a. What is a is the now you can see here I will supposing my a is the dividend, so a is dividend, and second is division, which variable I just taking. Okay, division, which is b. Okay, nice, there is no. Okay, and why I do it unsigned? Because the a is a vector type, you have to typecast into the unsigned variable. Okay, b is also a vector type, you have to typecast in unsigned. So just basically this function, this is means I typecasting to vector something to unsigned number. You have to use this function, you have to import the numerator, descriptor all. Okay. Okay, nice. Now third here, the third is the quotient and the remainder. I do something this, the others is equal to others and arrow is 0. This means that I initialize the each and every bit of the quotient variable. Here it's the 8 bits. Okay, here is 8 bits are assigning to 0, means quotient is 8 zeros and remainder is 8 zeros. I think you can understand. It's very basic, very basic. So first of all, process, you give a and b as a parameter, then a and b, which is which are a and b, basically which things a and b is the input pins, so only the input pins. Okay, there is no need to give the output pins. Okay, then in this here we need some variables, so I'll take variable division and dividend, and which type is unsigned and having 8 bits. Okay, 7 down to 0, 7 down to 0, 0, 7 to 0 means there are 8 bits. Okay, and like unsigned, and then the process will begin. Here the process, some variables and in the begin, and some variables and the those variables are assigning some values. Okay, now come to my algorithm. Here we start the algorithm. First of all, we have to check if you know that if I divide by 0, something divide by 0, then it will not make any sense, it will give undefined, so I will ignore the case. Okay, so if division is this yo, see this, what is this, you can say, so what is this, it is here I, what is basically what is, it is slash and is equal to. Here slash is equal to means not equal to. Okay, in other programming language you can see that the exclamatory is equal to, that is called as not equal to, but here it is slash is equal to, means is not equal to, means if the division is not equal to 0, then only I will do something, whatever I do then only do, if not, then I will just here start if and then end if here, and I will do nothing do, and just the value of the quotient it will be eq, and something just rest will be done, but nothing will be do. I come to this part also, you can just now skip, but I will come. Okay, suppose now I will assuming our the bit is not 0. Okay, the division is not 0, and I will go in the algorithm. So to understand the algorithm, I will give you some example, and assuming here I use the 8 bit. Okay, but it is not possible to show a 8 bit number, it will take more time. I will show you for 3 bits. Okay, now just see the algorithm, and I will show you in my pen and paper. Okay, pen. Okay, just show and just see. Okay, whatever. First of all, division is first of all I will show you the, here see division. What is division? Suppose division, what is division? Division is 101. What is 0 1 0 0 1 0 is 2 in binary. Okay, now what is dividend? What is dividend? Dividend is here I will take for 6. Okay, I will take for 3 bits. Okay, here if the algorithm is 7 bits, but no problem, if there is 7 bits I will compromise, take it 3 bits, and just say algorithm will be same now. Okay, just bits are different, but okay. Now and then the quotient, you can see that all the bits are assigning with 0. See that, see here I will assigning with 0, all the remainders are assigning with 0, remainders also is assigning with 0, so I remainders also assigning with 0. Nice. Okay, no problem. Next, if the division is not equal to 0, yes, your division is not equal to 0, so I will go and further and go in the algorithm and use. Okay, first of all, what it will do, it will run a for loop from 7 to 0, means you can just think, I think 0 to 7, so 0 to 7 means how much, it's total 8 bit. No, 0 to 7, 0 to 7, how many times it will run? 0 to 7 means it will run for 8 times. Okay, 8 times. So what is 8 times? What is 8? 8 is the maximum number of bits in the each or division or dividend. Okay, so For here how many for here my example every bit is 3, so I have to use 3. The I have my loop will be run for 3 times. Our loop will be run for 3 times. Okay, nice. No, now remainder is equal to, now see very closely these things. Okay, remainder is equal to 6 down to 0. 6 down to 0, remainder is initially 7 to 0. I will just discard the first bit. I'll just discard the first bit. I'll discard the first bit. Okay, what will be the next? The in the first iteration it will be 0 0. Discard the first bit, and it will just discard the first bit, and the dividend, and the first bit of dividend will be here. First bit of dividend, what is dividend? 110. The first bit of dividend means this one, this will be transferred here, this will be transferred from here. Okay, nice, no problem. And now see, dividend will be 6 down to 0. How initially it is 7 down to 0, 7 to 0 0 0 0. Then now it will 6 to 0. Then also I will discard the first bit. First bit will be discarded. First bit is 0. Now it will 1 0, and just adding a 0 in the last. Okay, adding a 0 last. Okay, I think you have understood. If you not, then the loop will be go more 2 times. This is a 5 size iteration. Now check for the second. If you not understand, I will show you the next two. If you understand, if the remainder is greater than equal to from the division. Now check what is your division. Your division is 110. 0 1 0 0 1 0 0 1 0 means 2, and here you have 1. So no, this condition is absolutely false. So you have not execute this. You have to not execute this. Okay, this part will not execute. But as the loop will not end, it will go and check for and go here, and it will run again. Okay, so for next iteration number 2, what will happening here? See very closely. The remainders again same things will happen. Same thing will. What will the now you have to come imagine that the here is not 7 down to 0. Here is 2 down to 0. If you do think that the it is 2 down to 0, then what it means? 2 down to 0 means the 2 bit. Okay, the 2 will be go 2 will be go the 2 will be if it is 2 down to 0, then according to the algorithm it will what will be, it will what 1 down to 0. Now 1 down to 0 means 1 down to 0 this part. Okay, this part, what is this part? This part is just this part. So 0 1, and it will be discarded. And the dividend of the 6, dividend of 7 means the first bit. What is the first bit? Is the first bit of the index. What is the index of first bit? Here is it 2, so it will go here. Okay, means here I think I can just clean a bit. Okay, nice. Now see here it will 1. Okay, I will just mark it, so you can, it will go here. Now it will 0, this 0 is shifted here, this 0 is shifted here, and another is another 0 is come here, so 0. Okay, nice. You can see. Now see. Now if the remainder is equal to, is this condition is true? I think is. What is this? It is 2. And what is your division is? Sorry. What is it? What it is? It is 3. Now your remainder is 3. And now what is your division? What is your division? Division is your 2. 3 minus 2 is 3. The remainder is big now, so you can do this part. So what you have to do? The remainder minus division. So remainder will be remainder will be replaced with remainder is equal to remainder minus division. Remainder is replaced by remainder minus division. What is your remainder is 3. What is your division is 2. So 1. 1. Nice. No problem. So 0, 0, 1 and 0, 0, 1 and rest is same. Okay. Okay. And the last iteration. Okay, third iteration. In the third iteration, what it will do? So see, now it will go for this line, okay, 26 number line, okay, and then it will then shift right once more, okay. Then what will it will do? It will this will shift here and it will fall out. So 0, this is 0, this one, and it will here 0. Now it will come here 0, it will come here 0, and this is 0. Now see, if the condition is true, yeah, the condition is true, yeah, absolutely. So it will replace with 0. This will 0, 0, 0. As your remainder and division is same, is 1, 0, and the division, your division is also 1, 0, means the both are 2. And now you just forgot to do one thing, that the quotient of 1 is calculated when the value of the when the first iteration, okay, when the iteration when 0, okay, 0 time, there will know when the iteration is 2, okay, iteration is 2, then the q will be is equal to 1, and the iteration when is 3, sorry, the iteration will be 2 is 1, and iteration will be 3 is also 1. Why? That the next part will be true for I is equal to 2, and the next part will be true and I is equal to 3. So this will be 1, 1. Okay, nice. It will just this line, okay, this line I explained this line, okay, which I just forgot. And then and it will also 0, 0, 0. Now if you see that you have got all the things. Your remainder is this, I marked. Your remainder is this, okay. Your quotient is this. How it is your quotient? See, okay, which is 3, 1, 1, 1, 1, means here 1, here 1, it is 0, okay. So what you are just doing, you 6 divided by 2, it will 3 and 0, quotient is 3, and remainder is 0. Is it so? Yes, yes, that's this thing. And now, and the last, if you if you just end the loop, and in the loop, and then end the if, okay, last if, the non divisional if, and last you assigning your pin, output pin q. What is the q? It's output pin your. So output pin has a quotient, strategic q, and the output pin of remainder, it will remainder, and you have to typecast in the factor type, and this is the algorithm, okay. So I think you makes sense now what is the algorithm saying. Very simple and small algorithm. So here is also the test bench code. This is so easy, and I will show you in the code, okay. So see the code now. See the just RTL or just icing, okay. So see, here is your code. The code same code, okay. Just there is no different. You can see just okay. I already done the RTL. Just save the time, okay. See, okay, this division, and you just, if you see the inner part of this, then you will see it will just like this. Because when the loop is running now, so the same thing will be do again and again and again, okay. So this like this, okay. Just forget it. And now the test bench, I want to just to uphold the one thing. Okay, see here I use a function called to unsigned. I think you can understood what is the two unsigned means. Two unsigned means you have a if you give two parameters to the two unsigned function. One is the number, you have to convert it into unsigned in binary format. Okay, the two unsigned function is basically do the binary conversion. If you give a decimal number, suppose here I give the 20 as a number, then it will convert into the binary form by the two unsigned function. And the what is the second parameter? I think you can guess, it is the bit number. How many bits are you are going to use here. Okay, here I use the 8-bit divider, so I give here 8. If you use 3-bit or 4-bit, then it will give you like 4. You can use the two unsigned function. Okay, everywhere. If and also if you use the two unsigned function, you have to import the numeric std.all library. Okay, and then say here I just 20 divided by 4, it will give 5. Second, some like case are there, I just give the test case. So I just I will just show you the icing. Okay, then you can understand. See here, see closely, the 20 it will convert it, this is 4, it is already converted. Then the see the quotient 10101, is it is 5. You can know it is 5, and the remainder is 000. Say second, what is the second? You can just go and check. The second is 25 divided by 6, it will give 4. Okay, and remainder is 1. Let's check. Okay, is it working or not? See, remainder is 1, and the division quotient will be 100 is 4. Okay, that's good. And divided by 6, 116, and it definitely the 25. The function will not do the wrong job. And you can see, and the see the if the division is all the zeros, okay, then it will not give it will not pass the whole for loop. Okay, now the for loop, but if else part it will keep skip and just go the last two parts where the I'll just assigning those values. So you can see the code is run quite well, and I'll give you the my website link. Okay, now so you can go through it. So okay, nice.